All right, parent functions day 2. Again, this is going to cover some attributes of the functions. So today's topic is what? Piecewise functions. A lot of times when people see that word, they get scared. They're like, I don't know what a piecewise function is. A piecewise function can mean it's just different pieces of different functions stuck together. So maybe it's curved, maybe it's straight, maybe it's got different parts. So we're going to begin by going over a kind of a review of your vocabulary. So is this graph continuous? Yes, that's easy, right? Does it have an x-intercept or more than one x-intercept? Just one. Right there, right where you touch the x-axis is an x-intercept, so that is 3, 0. And make sure if you're here, your mask is up. And I want you to write this as a point. Now, I know that Math Lab and some of the other things will take it if you just write a 3, but that's just a bad practice, okay? I want you to see that. Okay, is there, wait, we didn't put Y-intercept on there. Let's add Y-intercept. Can you see a Y-intercept? Right there, what would you say that is? 0, 1.5. Right? If it's in between, you're going to take your best guess or what's close, right? Does it have an absolute minimum? That means, is there a lowest point on the graph? Is there a lowest point? Right here, and where is that point? Where is that lowest spot? It's at 0. Make sure that you've got the Y value in there, right? So if it says, is there a minimum Y value or the height? Is there an absolute maximum? No. Is it okay to write none as an answer? Yes. Is there a local minimum? Meaning it's a minimum for those around it. Well, is this a local minimum? That's a local minimum, right? It's the lowest point right here. And it is where? A local minimum. Would I be wrong if I wrote the point -1, 1? When you see the word minimum, they're referring to the Y, where's the lowest or highest point. If it's looking for a vertex or it asks for a point, then you would give the point. Is there a local maximum? Yes, there is. At 2. Let's write a note. Just need when you go into different softwares like Math Lab or Delta Math, if they tell you they want it as a point, just write it as a point. But usually when you see max or min, now if I'm asking for a maximum point, then I want the whole point. Okay, let's talk about increasing and decreasing. We practiced that last time. We wrote down what that was. So I'm going to do my increasing in orange. And what's the rule of thumb about increasing? My pen should go which way? Up. I'm going to trace left to right. So this is down. So there I'm going up. Now I'm going down. Now I'm going up. Now where are my decreasing intervals? We'll write them down in a second. I'm going to do my decreasing. And in blue, now we're always traced left to right, correct? So here we're going down. Then we get there, we go up. And now we're going down. Does that make sense how you can look at a graph and see? I actually thought this was confusing when I was a kid because I'm like, well, I can go this way and that's going down. You can't trace backwards. You have to trace your finger like you read a book. Okay, so increasing is where? from -1 to 1. I'm not going to put my parentheses yet. And also where? From 3 to infinity. Infinity is always a parenthesis. Now I like parentheses here, right? Because this point, see this dot right here? It's shared between the orange and the blue, right? Can either side really claim it? Since neither side can really say, well, that dot belongs to me, it's shared, I like a parenthesis. If you look in textbooks, they'll use a parenthesis. The AP exam will allow you to do brackets there. So you may have to play with that when you're in different software. I believe MathLab wants parentheses. So when you're in a software, you may have to play a little to see what it is that they want. That's not a hard set. And we want to make sure use X values, right? A lot of times when it gets real low, people look at the Y value, but when you talk about increasing or decreasing intervals, you're saying where on the X-axis to where on the X-axis, right? All right, let's do decreasing intervals. So where is that? Negative infinity to -1 and 1 to 3, right? Constant, are there any constant intervals? No, there's none. Constant would be flat, correct? What is the domain of this creature? Remember, that means left, comma, right. So what's the domain of this guy? The left goes where? Negative infinity, the right, positive infinity. If I have arrows on both ends, that's going to be my domain, no breaks inside. The range, where's the bottom? Remember, range is bottom, comma, top. So where's the bottom? 0. Where's the top? Infinity. Infinity is always a parenthesis because you don't reach it. Now, do we actually have a dot at 0? Yes, so it's a bracket. Remember, parentheses are not inclusive. Brackets are inclusive. So if you get to include that number, we want to use a bracket. Where is the graph concave down or concave up? Okay, so this part right here, right, is concave up. What's this part? Concave down. And then what's about this part? Concave up. Okay, so it's concave down where? 0 to 2. And again, this is an estimate for you because you don't have the math to do the math part. You just do it with your eyes. Concave up would be what? Negative infinity to 0. And 2 to infinity. Now, what's your visual aid to figure out where it switches? You imagine driving a car on that road, and when you straighten your wheel out to go the other way, that's where you switch concavity. And what is that point called where you switch? Point of inflection, okay? And again, this topic will just be very visual for you this year, just looking at a curve. All right, what about reading? When we say F and we have a number in parentheses, is that an X or a Y? These are X's. It wants you to find that X and tell what Y is at that point, right? So we go to -1, and what is Y? 1. We go to 3. At 3, what is Y? This one says I'm supposed to add -1 and 3, so what does that mean? 1 plus 0, right? I put the Y's in, and what's the answer? 1. What about this one? What's F of 1? Go over to 1, it's 2. And that's times -1, 1 equals 2. So just kind of reviewing that notation with you so you're not confused about how to plug things in there. Is that okay? All right, now that we've looked at the parts of functions and revisited the vocab from last time, we're going to look at a real piecewise function. And you can see here, a piecewise means I've really got 3 different functions, and I'm going to use part of all of them. So let's say this overwhelms you and you're thinking, oh, I don't know how to do that. Just look at this right now. What is -2x minus 4? It's just a line, right? So let me just graph that. I'm going to 1, 2, 3, 4. Here's the beginning stage, -2. So it's up 2 over 1, up 2. Right? There it is. And I'm just going to draw it like I would. There's that line. I did it really light in pencil because I'm going to, what does this tell me? Only between -4 and -1. So I go 1, 2, 3, 4. So I need to keep going, right? And then I'm supposed to stop at -1, and -1 is a parenthesis. So this should be an open circle, and I really don't have this. So if you have trouble seeing just a small part of a graph, if it doesn't make sense to you to draw a tiny, tiny part, then just draw the whole thing really lightly and erase it off. Does it make sense what these numbers are for? This is your domain. So the graph only exists between -4 and -1. Now, -4, what does that look like? Again, I'm going to draw it big, right? But where does this exist? From -1 to 1. This one is a dot. This one is an open circle. Now I'll erase off the rest. Now, you don't have to do this. This is an option for people who have trouble seeing a part of a graph. You'll get to where you don't have to do that. And I might also do this. I might say, okay, I'm going to color that graph green so it's easy for me to see where it is. Now I'm going to color this one blue, so that's easy. Color coding is kind of handy. Now the last one is 3x minus 5. So that means I'm 1, 2, 3, 4, 5. And I'm going 1, 2, 3, 1, 1, 2, 3, 1, 1, 2, 3, 1. And where does this exist? From 1 to 3. So it's only right here. So I don't need this other point. I'm not going to continue. And it's got brackets on both. So I'm going to do this one. Okay, so that's a piecewise function, meaning we took pieces from different functions and they're on the same graph. Now, this tells you f of 1, so you have to go up. Here's a question kids always ask on a test, and I can't answer it on the test. They think they're supposed to plug 1 into every one of those, and they're like, what do I do with these 3 answers? No. 1 only lives in one of these domains, right? 1 does not live between -4 and -1. -1 to 1, does 1 live here? No, because that's a parenthesis, so I can't include the 1. So I have to follow this rule. So it's 3, right? You just plug it into that equation. And what is 3 minus 5? Does that make sense to everyone? How you figure out where you're going to put this? 0. Which one of these rules would contain a 0? Right there. And there's nothing to do, right? A lot of times here, people say, well, how do I plug that 0 into -4? You can't. If this is just a number, then that's your answer. You don't have any work to do. What about f of -3? That would be in this domain, correct? And you can also look at your graph and say -3 is on the green line, and there's my green line. So I'm going to have -2, times negative 3 minus 4. So that's 6 minus 4, which is 2. That's algebraic. I could also go over to the graph and go to negative 3 and see that I'm up 1, 2, right? So you can read the graph or you can read the equation. You want to be able to do both. You might not always have both. F of negative 1. Do I use green line or turquoise line? I use turquoise because this says negative 1 and negative 1 is included here, but it is not included there. So what is my answer here? Negative 4, right? Are those okay? So I'm going to pause this for a second if you're watching. While you try to do these, I'm going to give you a minute to think and do those. What did you get for an answer? Increasing. Which one of these is increasing? The pink one's increasing, right? And I can look over here and say it's going from 1 to 3. But also if I know the pink line because I colored mine, I can just look at this, can't I? So there we go. And it's telling me that the 1 is inclusive by this domain. Decreasing, I can look and see green is decreasing, so I can just go to green and I can easily see this. Constant, this time we do have constant. And since they gave me a domain, that's easy for me to write down, right? Concavity, is there any place where this is curved? Is it legal to have no concavity? Of course, right? What's the domain? Now I have to look and see. There's a gap here, but on my domain, as I come down on this green line, it's now open, but isn't that number covered by this dot? And then I go over here and now this is open, but isn't it covered by this one? And it goes all the way. So are there any breaks in my domain? There are not. So it goes all the way where? Negative 4 to 3. I had to check if there was an open where there was no X, but right here where that doesn't include 1, 1 gets picked up right there. So we're okay, even though it's not hooked up, right? The range, now the range is different. There is a big gap in my range, right? So I have to account for this. So that's just the number negative 4. Can you have a range that's just one number? Yes, for a flat line. Right? Also, where else is the range? What's my bottom here? Negative 2. And how tall does that go? Goes up to 4, right? Okay. Continuity, is it continuous? No. I could say it's continuous from negative 4 to negative 1, and then it's continuous from negative 1 to 1, and it's continuous from 1 to 3. But I'm just wanting you right here to say, no, the whole thing is not continuous. Do I have a y-intercept? Right there at what? And please, for me, always write it like this. If MathLab takes it as just a 4, you have to go with that, but I really like you to see that. We talked about this yesterday. For a function, can we ever have 2 y-intercepts? You can have many, many x-intercepts. Can you have more than 2 y-intercepts or more than 1 y-intercept? No. What would happen for a function? What would happen if you had more than 1 y-intercept? Yes, you would fail the VLT, which is the vertical. Sounds like a sandwich, doesn't it? I'll have a VLT. I'll have a VLT on toast. No, it's not a BLT. Vertical line S. You know me, everything sounds like a snack. Okay. How do we so far? Are we thumbs up like, yay, this is easy? All right, then I'm going to give you a minute. You now, we did this one together. So I want you to attempt to graph this one on your own, and then we'll look at it together. So take a minute. Let's check what you did. Okay, this one says x squared plus 1. How do you graph x squared plus 1? Well, the plus 1 tells you up here, and we know it's a squaring function, so over 1 up 1, over 1 up 1, over 2, 4. So it looks like this. I'm going to do it very lightly, right? Now, where does this exist? Where x is less than 0. So I only want that part, correct? And now, because I did it very lightly, I could just erase that off. So if you have any trouble graphing a piece, sometimes it's hard to graph a little tiny part of a parabola. Now it says x is 2, where x is 0, y is 2. That's just one dot, right? Sometimes that feels weird because you're like, just a dot? That's all? Yes, that's all. And then y is 3 when x is greater than 0. So not equal to, but greater than. Is that okay? Do you feel like, okay, I got this? All right. What's f of 1? You can either go to 1 and plug in 3, or you could say, oh, 1 is bigger than 0, that's 3. And what's f of 0? Feel like you got piecewise down? All right. Here's an SAT version, or ACT, SAT type problem in case you're interested in those. It says use the function in number 6. So that's this one, right? This is the function. To find a given f of -3. So -3, which equation is that? -3 would be which one of these? This is greater than 0, so it's not that. This is 0, so x is less than 0. So we're going to use x squared plus 1. Do you see how you have to look at the rule and kind of follow it? And it wants us to find f of -3. So let's do x and f of x. And we got to figure this out. So f of x, -3 is a -4, right? So what do I do with that? Yes, I can say a -4 equals what? X squared plus 1, right? And then what am I going to plug in there? A -4 equals. So what's the answer to A? What's the most common wrong answer? Well, a lot of times people will write down 6 because they're trying to work fast and that it's an ACT problem. And you see a -4 is 10, you see a 10, you see a -4, and your brain puts in a 6. So always on a high state, well, any test, you know, take that second to make sure that you're adding. Very common, happens all the time, all kinds of math problems, not just on this one. Okay, lastly, evaluate the following function at the given values. So here's our function, and they want us to plug what? -5 in. So equals. If you're going to put a negative number in for x, put it in parentheses. That's your safety, because what is -5 squared? What's the most common wrong answer? Yes, people try to write -25 down. Oh, that's minus a negative, so what's it going to be? So this is really what? 28 1/5, right? I could multiply and change it to an improper fraction. I don't have to do that. What about this one? They're not having me plug in. So again, when you have to plug a number in math, your best bet is take this equation, put open parentheses anywhere where there's a variable, right? Rewrite your equation like that, always, this will help you a lot when you get to some stuff in calculus. Now put this guy in those parentheses. Right? You know what? That's a typo. We don't have a g of x. It is. Oh my gosh. Look at this. I wrote over it and didn't see it. Thank you. Look at that. I wrote right around it and didn't look at it. Y'all, blind in one eye, can't see out of the other. Thank you so much. I did not even look at that. See, now what would have happened to me on a test? I'm modeling for you. Be careful. How could I fix that to where I won't do that again? If I were taking a test. Now my eye is pulled to the right color. Thank you so much. So that's x squared plus 3. And what are we going to plug in? Okay, and what is m minus 1 squared? That means m minus 1 times m minus 1. Is it m squared plus 1? No, because you have to FOIL. So anytime you see something squared, write it down twice to remind you. Countless people will say, oh, m squared and 1 squared. No, it's really what? M squared minus 2m plus 1 and then plus that 3, right? So it's really m squared minus 2m plus 4. Is that good? Okay, that's it for today. Next time we figure out how to move stuff around.
Miss Coughlin.